Welcome everybody. Welcome to the December meeting of the Ottawa RASC. And I have to get this piece in just because I remember standing up here 11 months ago and giving you a heads up that this in fact may be the last year of the RASC. Well, this may be the last meeting. So end of the world in 3 weeks, according to some, not others. There. So if I don't see you here in January, it's been a pleasure. And if I do, well, this is just a rehearsal for my retirement speech next year. So there we go. If the world doesn't end, then we'll carry on next year, and we've got some really interesting stuff, some of which we're going to give you a bit of a heads up on tonight, later in the program. Also, if you want to celebrate the end of the world and not sure whether it's going to happen or not, we'll talk a little bit about a solstice event happening here at the museum there. So if you're going to go out, might as well go out in style, right? There we go. So we've got an event planned. All right, enough of that silly stuff. Tonight's program includes our 2012 annual general meeting, followed by Al Scott with his customary 10-minute astronomy news update. And then we have a special presentation on the solar eclipse that just happened for a lucky fellow that happened to be in Australia to witness it. Must be nice. We'll have our break, our prize draw, observations, and then we'll let Simon finish it off. Last talk of the year with an interesting piece on Valles Marineris on Mars. So hope you enjoyed the meeting. We've got some cool observations. Hi again. So it's my pleasure to present this award to an individual that's demonstrated a dogged perseverance in getting out and getting their equipment under the skies, regardless of the conditions, not just in the warmth of summer, but in the dread of winter. And not only getting out and observing and checking out the wonders that the sky has to offer, but also keeping a detailed log or notes of their observations. This is part of what makes an observer, it's sort of the differentiation between being a very casual observer, there's nothing wrong with that either, or moving into that next realm of taking it a step further. Keeping a log, a record of your observations is a valuable tool for anybody that's seriously involved in doing this type of pursuit. It lets you keep track of the things that you've observed. It lets you make notes in terms of anything odd that you've observed, any quirks with your equipment. If you're into imaging, it lets you keep a log of the times that you've used, any difficulties or surprises with your camera equipment, especially when it's like -15 or something like that. It's just a step along the way, and it's something that was done, I think, probably by more people in the earlier history of observing, something that I think a lot of people have gotten away from. But it is a valuable tool because you can go back, you can see what you've accomplished, and you can see what if you've noted anything, because you forget. You tend to forget things, especially if you've had quirks. You've got a bulky piece of equipment or something like that, and maybe the sky is cloudy for another month or something, and you forget the fact that you had to repair this connection, or you had to tweak this or clean that. So keeping notes is a valuable exercise, and to that end, it's my pleasure for his diligence in keeping those notes to award the Observer of the Year award to Mr. Gordon Webster. Gordon. Yes. Oh yes, Gordon and his assistant Julia. Can't forget Julia. She's the one that actually keeps the notes, I'm told. So, hi.
She does the sketches.
She does the sketches. Oh, see, and I thought that was you. There you go, sir.
Thank you.
My pleasure.
Thank
There you go. Thank you.
Here, Julia.
There you go.
Okay.
Come on up front there.
Absolutely.
Hold it up.
Gordon. You can keep that there if you want to just
Thank you.
tuck it there.
Yep.
Thank you very much. Congratulations.
Where's Julia?
I did present this award at the annual dinner, but I'd like to repeat it obviously for the members that weren't there. We had a broad array of really top-notch presentations in the last year, and so it was a difficult choice to find the one that sort of merited presentation of the year. Certainly there were a lot of technical presentations. There were a lot of presentations that had a lot of information, a lot of beautiful imagery. And we decided on this year to give this award to somebody that demonstrated a lot of courage and guts to do what he did in giving his presentation. It's my pleasure to have awarded that presentation of the year to Nicholas Zuger for his presentation on how he got into astronomy back in March of this year. Is Nicholas with us today? Is he? There you are, Nicholas. You want to come up for a sec? Okay, just wait. That's good. I commend Nicholas on his presentation. I thought it was very slick. I thought it was well organized, and for a young man to step up in front of a seasoned crowd of critical observers such as you all are, I think that took a lot of spirit and a lot of dedication. So it was my pleasure to award that to Nicholas. Thanks again. Thank you. Thank you. Thanks, Brian. Thank you again. Congratulations.
Thank you.
And I'm expecting to see more presentations. He's going to be the guy to beat, for sure. All right. Back to you, Al. Thank you.
Is Drew or Janet here this evening from Astros? Janet? You want to come up and... The astronauts article of the year was presented at the annual dinner, but I'll ask Janet to come up and actually introduce the winner again to the membership here. Thank you, Janet. There's your screen.
Okay. This is unexpected. Do I need to do anything with the screen? I've been working with Drew Hodge since about beginning of July, and we have worked very hard to bring astronauts into the 21st century. And I don't know if you saw the last edition that we did, but we actually had it in embedded video. So I thought that's great. We're really moving along. Anyway, I just want to reiterate Al's comments about your contributions are what makes a really good newsletter, and it goes out to people who can't always make these meetings, so please keep that in mind when you're doing a presentation. But this year, we want to award Estelle for her Rother for her wonderful monthly meeting reports. She does a fabulous job. I have very little editing to do. They are so thorough. So let's give a round of applause to Estelle Rother. Thank you.
Bring your notebook.
Yeah. They don't put my tape
Hope you count the number of claps.
Just if you stand over there and just like that.
I'll shake your hand. Thank you so much.
We're doing pretty good.
Thank you.
Thank you, Janet. Done a fabulous job with astronauts. Thank you for taking that on. So the next item up for bids is the election. This is the duty of Paul Harrison, our past president, but since he's not here, I'll take over. So here you see a full slate of nominees for the Ottawa Centre Executive. President Gary Boyle, Vice President Gordon Webster, Secretary again Chris Tarrant, Returning Treasurer Hans Brower. All 3 councillors returning, Yves Demare, Carmen Rush, and Stephen Norse. Meeting Chair Paul Cloninger serving his 2nd year. National Council reps, we have Rick Wagner and Bill Wagstaff volunteering to take those roles. And I'm going to be going into the past president's role, and I don't think I can be unseated in that this coming year. So I guess we move to elections. All in favor? There we go. All positions are acclaimed. No need to vote, I guess. Before we move on, I'll just mention the council-appointed positions for volunteers who like to help out on some of the various tasks of the council. Estelle is continuing at the book library. Chuck O'Dale is taking over as webmaster. Drew and Janet continuing as astronauts editors. The Fred Lossing Observatory Director, Ron St. Martin. SmartScope Director, Jim Maxwell. We've traditionally had a position of Light Pollution Abatement Chair, which is currently open. If anyone is interested in tackling that role, please contact Gary or the council. Also, Public Outreach, Stephen McIntyre is stepping down this year as Director of Public Outreach. It's a relatively straightforward position where you field requests from the public and collect volunteers and make them all go to the right place at the right time. Also, as a part of this, Stephen was doing the star parties, the monthly star parties that we have during the summer. We were looking for people to help out with our star parties. If you're interested in helping to organize with this, making sure the lights are turned out, and checking the weather the day of and telling people whether or not to show up. Hospitality, Art and Ann Fraser are continuing. Loan Library, I'll continue to take this, but if anyone's interested in learning about how to hand out telescopes, I'd be more than welcome to help. And membership, Art Fraser. Thank you. So, other business. Is there anyone who has other business they would like to bring forward at this time? Very good. So, motion to adjourn. Anyone? Anyone? Janet? Thank you. So, you don't have to vote on that. So before I hand things back to Paul, I still have something I'd like to do is handing out these membership pins before Gary takes over his official duties as president. You can see here we have various holders of these membership pins. This year, before I move on to the actual ones that we can hand out tonight, we had a few people that have graduated categories. Art Fraser was received his 50-year membership pin at the annual dinner. Congratulations, Art. For 40 years, we had 2 members moving to that category, Lou Cox and Rick Wagner. And they had their pins as well. So for 30 years, we have 1 member moving on to the 30-year milestone, Derek McLeod. Derek, are you here? Come on up. I just happened to have left all the pins in arm prayer tonight. But come on up. Come on up. As a consolation gift, I've got a nice little trinket from ComDev here. And I'll get you your pin.
So I can get that back out a bit.
Congratulations.
Just want to take the phone. Can you guys actually just go grab it, please? Thank you.
The artist.
Yeah.
No, don't
No, that forward.
Over.
Oh, you're
You've got something on your head.
I'll get you your pin. And we have one 20-year graduate, past treasurer, Stephen Norse. Stephen, are you here?
He's in Hawaii.
He's in Hawaii.
I volunteer to go down and give it to
Good job. I'll hand you all the pins when I can find them. Youth members. We have 3 new youth members this year, in addition to the ones that have already got their pins. Flora Lawrence. No. Lachlan Robertson Martin this evening. John Nguyen. No. Okay, I'll send those out before I retire as president, and then I'll hand over the duties of pinmanship to Gary. So, thank you very much, guys.
Well, thank you very much, Al, and I want to add my 2 cents worth. I want to thank you for doing an outstanding job as president over the last 2 years. Thank you for your dedication and your energies. Much appreciated. Yeah, this is just an interesting little piece that Bill sent our way. If you've always wanted to see the space station and never know exactly when and where to look, there's a service now from NASA where you can basically sign up and they will give you alerts based on your location, and they will give you a sort of a heads up of where to look and when to look for the passage. If you've never seen the ISS pass overhead, or you think you've seen it but you're not sure, it's really a very cool sight, especially when you've got another spacecraft attempting a rendezvous and docking with a station there. I've seen that a few times there, where you've got these 2 brilliant lights passing overhead, and it's quite a sight. The station itself is very bright. When it does a high pass over your head, it's brighter than anything else in the sky except the moon and the sun. So it can be very, very brilliant. Well worth seeing, and so you can sign up for an email alert and see some of these passes. So nice service. Thanks for passing that on, Bill. Appreciate that. All right. Now is your turn.
Okay. Thank you. Okay, I'll try to be brief since you're probably all getting bored of seeing me up here. A couple interesting news items this month. The ESA's Planck satellite, which is a cosmic microwave background observing satellite, has discovered a bridge of hot gas that connects galaxy clusters Abell 399 in the lower center and Abell 401 in the top left of this image. The galaxy pair is located about 1 billion light years from Earth, and the gas bridge extends approximately 10 million light years between them. Planck's primary task to capture the ancient light of the cosmos, or the cosmic microwave background, faint light that traverses the universe. It encounters things on its way between the very distant echo of the Big Bang on its way to our eyes and our satellites, and it interacts with them. And the interaction of this cosmic microwave background with this gas actually changes the properties of the microwave background. And Planck is the first satellite that has the resolution that's able to notice these small localized features. 10 million light years doesn't seem that small, but from 10 billion light years away, it really is kind of small in terms of the angular size of it. So it actually, the background radiation interacting with this, with the foreground dust and gas, is called the Sunyaev-Zeldovich effect, after the scientists who discovered it. Planck has actually discovered previously unknown galaxy clusters using this effect to measure the changes in the background radiation that are coming to us. And this is the first time it's actually discovered gas with no associated galaxy cluster. In the early universe, filaments of gaseous matter pervaded the cosmos in a giant web, with galaxy clusters eventually forming in the densest nodes. Much of this tenuous filamentary gas remains undetected, but astronomers expect that it could most likely be found between interacting galaxy clusters, where the filaments are compressed and heated, making them easier to spot. Planck's discovery of the bridge of hot gas connects these two galaxies, each with hundreds of these two galaxy clusters, each with hundreds of galaxies. The presence of hot gas between the billion light-year distant clusters was first hinted at in X-ray data from ESA's XMM Newton satellite, and the new Planck data confirm the observation. It also marks Planck's first detection of intercluster gas using the Sunyaev-Zeldovich effect technique. By combining the Planck data with the archival X-ray observations of the same cluster from the German satellite ROSAT, they actually can estimate the temperature of the gas in this bridge, and it's found to be similar to the temperature of the gas in the two galaxies, around 80 million degrees Celsius, which is why it's detected in X-rays. It's actually emitting X-rays. But it's very, very tenuous. I mean, this is supposed to be dense, but I mean, it's dense in terms of intergalactic medium, where you have one molecule per cubic meter or something like that, or one atom, I should say. So a very interesting discovery. My second item, cosmic duds. This is not so much observationally based, but based on computer simulations of type 1a supernovae. Supercomputer simulations have revealed that a type of oddly dim exploding star is probably a class of duds. Peculiar type 1a supernovae are probably white dwarf stars that failed to fully detonate. Most of the thousands of exploding stars classified as type 1a supernovae look similar, which is why astrophysicists use them as accurate cosmic distance indicators. This is what they've used to detect the expansion of the universe associated with dark energy, which was awarded a Nobel Prize. By measuring, assuming the brightness is relatively fixed, because these white dwarf stars exceed a certain radius, the Chandrasekhar limit, they basically implode into a supernovae, and because that mass limit is the same throughout the universe, they feel the idea is that the energy in these explosions should be relatively constant. Well, in 85 to 90% of the case that's true, but about 10 to 15% of these supernovae seem to be anomalously low in brightness. The models that have been done show that basically what happens is that they ignite a flame. When they exceed a certain level, they actually have a center of ignition near the core of the star, and they have this explosion that burns, but it isn't followed by a triggering of a detonation wave that goes around the star, which causes the high-powered supernovae. These findings were based on simulations that consumed approximately 2 million central processing unit hours on Intrepid, the blue Gene/P supercomputer at Argonne National Laboratory. The scientists have been successfully simulating regular type 1a supernovae explosions following the gravitationally confined detonation scenario for years. But in this scenario, what they did was they found that the white dwarf begins to burn near its center. This ignition point burns outwards and floats towards the surface like a bubble. In a regular type 1a supernovae. After it breaks the surface, a cascade of hot ash flows around the star, collides with itself on the opposite end, and triggers a type 1a supernova detonation. In the failed detonation scenario, which is these 10 to 15% of oddball ones, the white dwarf experiences more ignition points that are closer to the core, which fuels more early burning than in the detonation scenario. The extra burning causes the star to expand more, preventing it from achieving temperatures and pressures high enough to trigger the catastrophic supernova detonation. Instead of detonating, the white dwarf remains intact, though some of the star's mass burns up and gets ejected from its surface asymmetrically. The resulting white dwarfs can have anomalous concentrations of heavy metals on their surface. They could be non-symmetric, and they could end up with getting velocity kicks of hundreds of kilometers per second in one direction. Some of this model actually explains some very anomalous observations that have been seen by astrophysicists in the past, and this will help us to refine our measurements of the expansion of the universe due to dark energy by being able to account for some of the outliers that didn't fit the rest of the curve. So this is really an interesting simulation, and with millions of hours on the Argonne supercomputer, it's obviously been recognized as very important by the people who hold the keys to those things. So interesting times ahead for the prediction of dark matter and dark energy. All right, thanks.
Interesting times indeed. Okay, we have a presentation from Shinya Sato concerning the total solar eclipse that occurred that was only visible in a very limited portion of the planet, unless you were on a boat out in the middle of the Pacific. Mr. Sato was fortunate enough to be in Australia just a few days ago to capture some images and an experience. Are we here? Oh, are you? There you are. Great. So without further ado, please. Come on.
Oh, sure.
Yeah, it's all yours. Thank you.
Hi everyone, my name is Shinya Sato, and last May actually I went to the Albuquerque in the New Mexico to see the annual solar eclipse. So I really enjoyed the event, and basically the tons of people showed up the event, and so atmosphere was really good, and so as soon as the event was done, I decided to go to the Australia to see the total solar eclipse. So so next, please. So that actually that as I used the air mile, so I had to take many stops so to get canes in Australia. So I flew from Ottawa to Newark, so Newark to San Francisco, San Francisco to Sydney, Sydney to Brisbane, so Brisbane to Cairns. So almost actually 24 hours flight. And so when I got Cairns, I was really tired, and but you know, it's almost free flight, so I cannot complain about that. And so next, please. And so this is a path of the totality. And the width of the shadow of the moon is about 100 kilometers. And maybe I just use from here to here. So this is a Cairns, and so the red line shows actually the center of the shadow. And okay, so next, please. So I was thinking of two observation sites, and one of them is Palm Cove Beach. Actually, this is a Cairns. So this is a Palm Cove Beach where I stayed. So Palm Cove is very close to the center line. And the other one is a city called Mariba, I guess. So, and Mariba is located here, actually just 40 kilometers just east of the Cairns, something like that. So Mariba is actually close to the south limit line. So, but the Mariba is actually that the elevation is about 400 meters. So, and it's kind of far from the ocean. So this area it's more has a dry weather condition. But Palm Cove is just near ocean, so it's really wet condition. So and also the Mariba actually close to actually a little bit far from the center line. So the duration of the totality is about maybe 20 minutes shorter than the Palm Cove. And so weather condition was not really good, but it was really tough choice. And but I chose the Palm Cove, so just close to the center line. And next step, please. So I start set up at 3 a.m. It's really dark. And so I set up my Canon just T1i with a standard zoom camera lens, and also that Vogue 45 millimeter. It's for the capturing more larger solar image. So next, please. And so around 3:30, and it was really mainly clear sky, so I could see the Southern Cross, actually that, and was visible in the southeastern sky. So because I took picture from beach, so there's some palm trees, and I thought it's really nice.
Enhanced, be able to see the stars?
This one?
Is the image enhanced?
Enhanced. Hold on. Not really. Yeah, maybe a little bit, but not much.
Very good.
And so next, please. So on the totality actually start at 6:38 a.m. at the Palm Cove. So the sun rose at about 5:30 a.m. So this is just the sunrise, and so you can see some clouds, and but still there's an open sky here. So and actually the totality is supposed to happen in somewhere here. So I thought maybe okay. So the next, please. So 5:53. So huge, crowds just in front of us. So, but still we have and about 40 minutes or something. So maybe because the crowd's really moving fast from south to north. Actually, in this picture, actually the right to left. So still I was and I thought maybe okay. So then, this next please. So actually it's getting worse. And 6:03, the most eastern sky was covered by clouds. So at that point, I thought I wouldn't be able to see the big event. So really, then actually I saw more something like somewhere here. I saw that raining, so that So next, please. So 6:15. So it's getting better, actually improving, and so we can see some sunlight from between the clouds. So still, I think the crowd was moving fast. So next, please. So 6:25. So finally, actually, we really see that the sun between the clouds. So I think at the 25. So maybe 15 minutes to go, right? So maybe there's some openings here. So maybe okay. So the next, please. So 6:29. So this crowd actually completely covered and the sun again, and so only just 8 minutes, right, to go. So maybe that point I thought I wouldn't be able to see that, and but so next, please. So just 3 minutes before the totality, so the eastern sky was clearing up, and so it's ready to see the big event. So next, please. So this is a 6:38. So we could see the really nice totality, and then actually image is taken every 4 minutes with my solar filter after the totality was superimposed. So I want to just make a very nice, the sequence of the eclipse, but I had to remove the most of images because of the cloud cover. And but still, it was really amazing moment, and it's really dark, and so I think there is some star around here, but just only 2 minutes. So, and also that I wanted to take a picture with a different setting, like change the exposure, something like that. But I couldn't do anything in the 2 minutes because it's really short. And if you do that, and maybe I couldn't see the actually, the eclipse. So that, I think to take a really nice picture, I think you have to really program or use multiple camera, something like that. Otherwise, it's really difficult. And so next, please. So this is actually the picture of the diamond ring. And so you can see the prominence, and here, something like that. And the next, please. And this is the corona during the totality. And so next, please. So, and I kind of collected some pictures from YouTube because I wanted to what it was from the different places. So this is my picture from Palm Cove, and those pictures actually was taken during the totality. So at the city of people, actually and people in the city of Cairns, actually basically they couldn't really see the totality because of the crowd. And and also I found that there's some blue sky something. So I think at the Cairns it wasn't really dark and compared to the Palm Cove. Maybe because the Cairns is pretty close to the center line, but maybe the shadow of the moon, maybe the size of the shadow of the moon was maybe a little bit small. And so that's why, and they couldn't, it wasn't really dark. And so I think at the Port Douglas, actually here, that's actually another popular place and to see the eclipse. So they actually could see a little, this is actually the totality, the sun. So maybe a little bit, they could see a little bit between the clouds. And so that Mariba, actually, there is no crowds. So they could see everything and from start to end. And but I found that actually the all images they are not calibrated in the same way. So but still you can they gives you the idea how it was. And so I think at the Mariba, no crowds, but I think it was probably and it didn't become as dark as the Palm Cove, I think. And so next, please. So next day, it was another clear night, and so I took a picture of the Orion. So actually, this is Orion, but kind of rotated to the left in the southern hemisphere. So, and this is actually M42. So usually, and so this is actually Betelgeuse. So yeah, it's kind of very strange, right? And I found some very familiar constellation, but in the southern hemisphere, it was really tough to recognize. Even if I know some constellation is familiar with me, but it's really difficult to recognize. So I think that's it. Right? Yeah, thank you very much.
All right. So first and foremost, as I mentioned, Mr. Commission.
This is M42 NGC 1976. This picture was taken with the Universe camera at my observatory with the 14-inch LX200 me telescope. Now, this is the end product that I did not create. I sent the original picture to Paul Cloninger and let him tell you what he did with it.
Okay. I went up to the internet Tried to find the best possible image I could. No, we've been helping Paul commission with his observatory because he's recently gotten the Mallancam Universe camera, and to really flex that camera, you need to take longer exposures. I know Paul previously with his other camera was taking shorter exposures, but with a camera like this, you want to capture the color, you want to capture the fine details there, so you need longer exposures. We've set Paul up with an auto guider, and he's happily clicking away there from his nice warm room. Lucky dog, you.
Yeah, it's color. Yeah.
And it's color. Yeah? So nice work, Paul. What this is, and surprisingly, this is a composite image. We shot a few that night. We're basically still shaking down the system and testing it out. But this is a layered composite of two 3-minute images, one of which was binned, and a single 6-minute image. So only 12 minutes of exposure in total. We layered them to reduce the noise and to bring out some of the finer detail in the closer to the heart of the nebula there. So not too bad for a trial image there, and I think we're going to see a lot of color stuff coming from Mr. Commission in the next little while. So I'm looking forward to that, Paul. Excellent. Thank you. All right, next up we have a blank. No. Roman. Oh yes, Roman. Yes, I'm Roman's surrogate here because Roman is on a distant part of the planet. There, Roman also observed. Where does Roman live again?
In Australia.
In Australia. All right, lucky dog. He gets a lot of eclipses down that way. So Roman sent us some images that he took of the recent eclipse of just a couple of weeks ago, and I'll just step through them. I don't have any of the technical details. But needless to say, he was in the path of totality. He took a sequence there. Obviously, the sun rising up through the trees as totality progressed. Or actually, I guess this is totality waning already. I'm not sure what part of Australia he's in there, but you can see there's a sequence there that he submitted to us.
I think it's Alice Springs.
Alice Springs?
Yeah, I sent him some stuff like a while back. I think it's Alice Springs.
Oh, okay. All right. Well, thank you. So, yes? Yeah.
Coming to Ottawa January, February. He should be here at the February meeting, and I hope he can give a talk on something.
Oh, wonderful. Okay, good. Thanks for the heads up. Appreciate that. All right. Thanks to Roman there. Morgan, Transit of Venus. And this is Morgan, the background, I'm sorry. Is Morgan here? Excellent. Come on up, Morgan. I wasn't sure whether you're here or not. I'll leave the floor to you. Here you go.
So about how close do I have to stand to this thing?
Oh, you're good. Just anywhere
Just
around
here?
Yep.
Okay. So it was actually Chris who wanted me to send in this picture. It was the transit of Venus using just welder's glass and a camera. We had to hold the welder's glass in front, and my dad took the picture. So it came really blurry because the camera was unfortunately focusing on the welder's glass and not it. But you can just vaguely see Venus, little dot.
12 o'clock high.
There you go.
And that's about it.
Nope.
Oh yeah.
One more.
You sort of see me looking confused. It's my younger brother. He's looking through the welding glass. You can sort of see it, a tiny dot with the welding glass, but it really did work better using a camera or a telescope. More pictures. I got a solar filter for my telescope that allowed us to look through, specifically for the Venus transit, and I've basically just used it for that and looking at sunspots.
Where were you observing from?
Our house, about Prescott Russell, it's about 60 kilometers from here.
We should all observe with wine in our hand. You mean you don't?
And the guy in the background pretending to be a ninja.
That's great.
That's it.
That's it? Okay.
Thank you, Morgan. I see a budding astrophotographer in the works. Here we go. All right. I've got a few for you as well this month. I traveled to Egypt to photograph this view. Not. Actually, for those of you that have been out in the last few nights, you may have noticed that the very bright moon has been dancing in around the Pleiades and up by Jupiter there. And this is just from a couple of nights ago. The sky was nice and clear, and I saw this and I thought, that is just such a cool sight. The moon was just brilliant there. The sky at that point in time was nice and clear, and I thought to capture this would be really nice. But the problem is that the moon is very, very bright. So to get a sufficient exposure to show the Pleiades and part of the Hyades down here as well as Jupiter, we had to get rid of the moon. So I positioned my camera under the edge of the roof of my house, and that's what the pyramid is there in the center. So that allowed me to take a longer exposure. So even under full moonlight, you can see that capturing a lot of fairly faint stars, along with the very prominent stars of the Pleiades. Without doing that little trick of occultation, you get this. The next slide. Bang. Yeah.
That's a much better photo there, Paul.
You like that one, do you? Thanks. So the background was photographed or imaged in 2 seconds, and you can see what that does to the moon. It just totally blows it out. But I want to show the position of the moon and some detail on it, so I superimposed a much shorter exposure. And again, just to give you an idea of how bright that moon really is, the background exposure was captured in 2 seconds. The moon exposure was captured in 1/4000th of a second. So yeah, the moon is, it's a testament to the human eye, though. When you think of it, I can look up there and I can see detail on the moon, and I can see the Pleiades, and I can see Jupiter. But when you point the camera on it, one shot just blows it away with the brilliance of the moon. So, ergo the pyramid. There we go. Yes?
It's worth mentioning too that this is very instructive in showing just how really tiny the moon is. Yet, even to my eye, after years of experience, when I look at the moon and then some night when the moon's not up, and I look at the Pleiades, I have to really convince myself that the moon is really smaller than that cluster.
It's true. Yeah, you're under the impression that it's larger just because it's so prominent. But this is the shot. I was actually looking at some astronomy planetarium programs, and I saw that the moon was going to be in this nice position between the Pleiades on one side and the Hyades on the other side. So the two of the closest star clusters to us here on Earth there. And I really wanted to get out and capture that view. And so same scale and everything else, just done with a 50mm lens, camera on a tripod, nothing too fancy at all. But yeah, the moon is proof positive that the moon is smaller than the Pleiades. Okay, a couple of weeks ago, I was out at SmartScope, and I was talking to Jim and Wolf, and I said, geez, guys, you know, that looks like an aurora that's forming in the north up there. I think that was November the 14th. That was around 9 o'clock. That was a busy night for me because we were doing some work out at SmartScope there, trying to bring it online there. And I think Jim was, by the way, sidebar here, I think Jim was being very modest with it. I think we're actually making good progress on SmartScope, and just an addendum to the stuff that Jim mentioned there, I think with any luck at all, we're going to have that scope online very shortly, so stay tuned. The next year could be very, very interesting, and we may see our first access to the membership for SmartScope, so we'll cross our fingers on that. Anyway, saw this auroral glow, and I wasn't quite sure it was an auroral glow. It was around 9:30 when we finished at SmartScope. And then I called Glenn and I said, I just finished out at SmartScope. Let's go down to Paul Commission and help him out with his telescope. So we rolled around down to Paul's place around 10 o'clock. We played with his scope and got things working. We were there until about 2 in the morning. And then I still had about a 70-kilometer drive home. So I didn't get home till about 3 in the morning. And wouldn't you know it, the aurora was still active, and it actually looked more prominent than it did earlier in the night. So it lasted for a good 6 hours, at least from what I saw. So when I got to my place at 3 in the morning, I went to bed and I didn't do anything. How can I resist an aurora? We don't see them all that often here, and so I grabbed my camera and tripod and just banged off a few shots there. And so I've got 3 just to show you there, and you could see the reds. You could actually see some of the reds there. That's a little bit more unusual. They're caused by a more energetic reaction with the incoming solar particles there. The green was quite prominent, and the aurora had a definite ripple to it. Like when you watched it down close to the northern horizon, you could see ripples coming through the visible part of it. So it was quite nice. And the last one, you got occasional spikes in the red like that, which were definitely visible to the naked eye. So these shots, again, just camera on tripod, 18 millimeter lens, exposures ranging from about 30 seconds to about 50 seconds, ISO 1600. So easy to catch. Keep an eye to space weather if you're interested in auroral alerts there. And we are approaching solar max. So we're hopefully going to see more and more of these before the sun goes into the more quiet part of its cycle. So stay tuned. All right, and the last one I have is this one. This is the Crab Nebula. I shot this a few weeks ago using a Mallancam Extreme on a motorized Dobsonian. So that's a very sensitive camera. It's essentially a video image. This is a stack of 10 30-second exposures. The crab, as you know, is in Taurus, and it is the remnant of a star that went supernova well, we saw it here about 1,000 years ago, but it really happened about 6,000 years ago, since it's about 5,000 light years distant from here. So remnant of the Crab Nebula there, or a remnant of that supernova event. And that's all I've got for you. There we go. Thank you. All right, and to conclude our evening, we've saved the best for last. There we go. Yeah, I know, Simon. Come on up here. Talk to us about Mars. Tell us about Mars. All yours.
Okay. All right. The Valles Marineris. That's the Great Mariner Valley of the planet Mars. It's the largest valley network in our solar system. In fact, on Earth, it would extend right across the entire USA from coast to coast. And it's an enigma still today. How did such an enormous valley network form in the first place? We know that once it was established, it was scoured and over-deepened by what we know were likely to be flash floods of water that emptied out onto the northern plains. Let's go to the next slide, please, Chris. Onto the northern plains at the eastern end of the Mariner Valley system. There's the Mariner Valley, and this is the end where we know that water flushed out and into the northern plains, which are all essentially most of the northern hemisphere. But there remains much debate over how the valley network was initiated in the first place. Now, one potentially important clue is provided by its location, and it lies due east of the Tharsis Plateau. That's this entire area here. And these three major volcanoes, then of course there's Olympus volcano just over the horizon there. Next one, please. Good. Now, more clues come from the European Space Agency, who released an outstanding high-resolution image. It's a high-resolution 3D perspective natural color image, which was taken by the Mars Express satellite back in 2009. And it illustrates a very small segment of the Mariner Valley network, known as Hebe's Chasma, which I presented to you, actually, in early 2010. Next one, please, Chris. Now, Hebe's Chasma is clearly closed at both ends. Here's the chasma seen in an older picture, but look, it clearly is closed at this end, and it's closed at that end. And what that means is that it could not have been carved out by classical rivers of water. They had nowhere to flow. So the question was, how did Hebe's Chasma form in the first place, and what might it teach us about the rest of the Mariner Valley network? Let's go back a slide there, Chris, please. Thank you. Now, planetary scientists who studied that European Space Agency image suggested in a scientific paper that Hebe's Chasma was initiated by material flowing down giant sinkholes in the floor of what is now part of the Mariner Valley system. And the number one sinkhole is actually right at the end of this internal plateau, right out there. Of course, this begs the further question about how the sinkholes formed in the first place.
Sorry.
No, let's go back to, there we go, we'll stay with that. And what they determined was, they suggested that it had to be that there were layers which were either able to melt under Martian surface conditions or dissolve. The thing that could melt would have been permafrost, but permafrost under Martian conditions doesn't have the physical strength to hold huge cliffs up, which are kilometers high like this, but salt does. So they suggested that what was actually happening was that there was water, groundwater in the system, which actually dissolved the salt, forming these sinkholes down which the non-salt material could then go to start to initiate this chasma. Well, there's a second 2009 European Space Agency image that we seem to have missed at the time. Maybe it's because they didn't actually advertise it. Let's go to the next one, please, Chris. Here's, next one, please. Thank you. And here's a label of the full extent of the Valley Marineris. Let's go to the next one. Thank you. This is the extent of the Hebes Chasma image. Next one. And this is the extent of the second high-resolution image of the entire mid-segment of the Mariner Valley. And this was re-released by the European Space Agency at the end of October 2011, which is when I finally spotted it. Now, before we leave here, let's just do a little bit of terminology. For some reason or another, planetary geologists like using Latin words. So instead of just talking about canyons and chasms, they talk about chasma for a single canyon, and chasmata, which is the plural. So if I use those terms, that's what I mean. Let's go to the next one, please, Chris. This is the image in question, showing you the topography of the chasmata that make up the Mariner Valley. There's Candor Chasma to the north. There's Coprates to the south. And then in here, you've got Melas, Ophir, and here up here, there's Hebes Chasma. And these chasmata all cut into a very obvious flat-topped plateau. You can see the flat top of the plateau here, and you can see it through here. And that's made up of light-colored material. Now be aware that this image, just like the original image I talked to you about in 2010, this image has a 4 times vertical exaggeration, and that serves to highlight the many details of the slopes, but it means that the topography doesn't actually quite look like this if you were actually floating off in Martian orbit. Now, the original work on Hebes Chasma came to my attention because scientists had already studied it and published their results. But for this, I've checked. I cannot find any science paper that gives ESA's interpretation, European Space Agency's interpretation of this image. So basically, that means it's open for both interpretation, deciphering, and/or speculation. And you're going to get a lot of speculation tonight. So let's start by looking at the most obvious feature, the chasma walls. Next one, please, Chris. What I'll do, in order for you to know where you are in the system, each of these pictures will have an insert up here, a location insert of the overall image itself, with a little green box showing you where we are. So here we are at the eastern end of Coprates Chasma, and this nicely illustrates the nature of the erosional features that decorate the light-colored steep chasma walls. Now, at first glance, you might think they reflect complex geological structures in the rocks of the chasma walls. You might think they're folds or something like that. However, next one, please, Chris. This slide from the western end of Ophir Chasma shows that this is not so. Note the smooth chasma wall right here, where there's clearly been a relatively recent landslide that's wiped the wall clean. There's the landslide. And note the very simple horizontal layering that's revealed in the uppermost part of the cliff there. And you can actually see it down here very, very faintly, but that's where you can see it the most clearly. So this apparently complex herringbone structure on the rest of the chasma wall, which you can see over here, there's the herringbone structure. This is simply the expression of slow, progressive crumbling of the light-colored material that the chasma is cutting into here, which suggests to me, with my geological background, that the light-colored material is likely to be a thick pile of undisturbed layers of sandstone or volcanic ash. Next one, please, Chris. No, that's okay. Turning to the western end of Candor Chasma, we can see the chasma head wall is retreating along 2 parallel trenches, here and here. Or can we? Is it? Let's have a closer look. First, look at the southern trench here. There's actually a link. There's a bridge going right across it. This trench here is not actually joined to the main chasma. And if you look at the northern trench here, it is clearly set well back from the head wall of the chasma itself. So what is going on here? Next one, please, Chris. This is even more striking down here. This is exactly the same kind of trench, but it's now clearly, very, very clearly isolated from both the other trenches and from the main chasmal wall. Next, please. So here's the isolated trench. Look closely and you'll see a linear feature here along its southern edge, projecting out towards the right. And along it, you'll see a sparsely populated chain of pits. There's one there, then again, and again, and again, and there they are again. And in fact, there's also another feature here parallel to it with much, much smaller pits. Where did the material that originally filled the trench go? Like Hebe's Chasma, this trench is closed at both ends. It's closed at this end and it's closed at that end. Maybe the trench was dug by wind. But if you look here, the slump here on the south side clearly indicates that material is falling into the trench as opposed to being dug out of it. Next one, please, Chris. So I'm going to suggest that these are collapse features formed, as in the hypothesis for Hebe's Chasma, by the removal of material at depth which created sinkholes into which plateau material could collapse to form what I refer to as structurally controlled collapsed pits and trenches. As the pits and trenches link up, the chasma head wall retreats and the chasmata grow in length. And in fact, it's interesting to just look at this one up here. Here's an elliptical to circular pit, completely isolated from everything else. But the only way this could have formed here, again, is that it's some form of collapsed pit. And I think this gives some support to the hypothesis I'm putting in front of you. Next one, please, Chris. But what provides the structural control for these structurally controlled aligned trenches? To address that question, we need to move to the preserved plateau area between Copertes and Candor chasmata. Now, superficially, these channels that you can see here, they look like a braided network of streams, but if you look closely, you'll see that many of them are segmented. Look here, for example. There we go, right there. Watch this. It comes as a segment and it kicks down, segment and kicks down, segment. There it is again, segment and it kicks down and again. And in fact, you can see it all the way through the entire network. Those segments are uniformly misaligned with respect to the overall channel trend. As a geologist would instantly recognize these to be tectonic fractures. And a structural geologist, which is what I spent the last 40 years being, would recognize that they formed in response to right-handed sideways shearing. But look even more closely, and you'll see that many of these fractures, you can see it quite nicely up here, are actually rifts. Look there again. They're flat-bottomed, they've got nice parallel sides, and then there's like a keystone in the middle has dropped down, rather like the Ottawa Valley. Now, given how long and narrow these features are, coupled with the evidence for their origin as fractures, most geologists would interpret these as magmatic dikes, vertical sheets of magma injected into fractures. The magma, injected from underground, never quite got to the surface. And as it cooled and solidified, it shrank, just like anything that cools does, leaving a space between it and the plateau surface into which the material collapsed, forming the long, skinny, segmented rifts. Now, these segmented fractures and dikes had a significant role to play in determining where the walls of Candor and Copertes chasmata would form. Next one, please, Chris.
Simon?
Yes.
Could you go back to that for a moment?
Yep.
Down in the left quadrant, all the minor craters there all have a dust trail or something down to the southwest.
Yep, okay, I see that, yep.
How do you explain that?
Oh, that's going to be a result of either oblique impact, or it's going to be a result of a northeast wind.
Okay.
Okay.
Yeah. Thank you.
Okay, good. So let's leave the plateau for a moment and look in the interior of the chasmata, starting with the western half of Candor Chasma, located here on the global image. Next one, please, Chris. What's the first thing you notice here? It's not as complicated as you think, the colors. The plateau material and the cliffs bounding the chasmata are light buff in color, but the floor of the chasma, and locally the lower parts of the cliff, there's the lower part of the cliff, but look at the floor through here, the floor here, and the floor through here. They're distinctly darker, and I would in fact call those colors medium gray to dark brown. Next one, please, Chris. Let's zero in on this area here that I've highlighted that is remarkably free of dust and rubble to see what the dark stuff really looks like. Next one, please. The material on the floor of the chasma here is very different in appearance from that in the plateau and the cliffs. The rock appears to be very smooth and homogeneous, and it's broken by short fractures that intersect each other at high angles. Look, there's a set of fractures which are oriented like this, and there's a set of fractures which are perpendicular to them, and you can see that pattern all the way through. You can even see it down here. But here, that grey material is actually overlain by a chocolate brown coloured material, quite distinct, with a very different fracture pattern. Look, these fractures here sort of form polygons rather than rectangular blocks. Now, I can't know for certain, because you've got to go there to actually ground truth this, but from where I stand, this sure looks to me like two sheets of dark magma, each of a different composition, likely similar to the basalts and other rocks that underlie the Earth's ocean floors. Next one, please, Chris. Now, before I try and draw all these threads together, I'd like to turn to further evidence for the processes that exploited the presence of initial fault systems to form the Valles Marineris that we actually see today. Now, here's the north wall of the eastern end of Copert's Chasma, where we can see two distinct stages of landslide formation. In the upper left here, there's a very clear landslide that's perched. It never actually managed to get all the way down to the valley floor. Yet. It will one day. Just keep an eye on it. And to the right, over here, is a landslide that dropped to the valley floor but was in part confronted by a buttress, a mountain range, if you will, in the floor of the valley, of high-standing rocks that it had to flow around. Next one, please. But landslides don't simply flow wherever they please. And in this example from Ophir Chasma, the landslide has been channeled to flow through here, between these two promontories, actually of resistant plateau material, on its way down to the chasma floor. While we're here, note the isolated collapse pit right here, clearly standing behind and disconnected from the chasma wall. I think that has to be a collapse pit. I can't think of any other way of explaining it. Next one, please. So, what happened to all that material that slid down the cliffs and onto the valley floor? Let's zero in on the floor of the western part of Condor Chasma and see. Next one, please. So here we see three different aspects of flow of landslide material on the chasma floor itself. At the top right over here, you can clearly see there's rubble that's basically still sitting at the foot of the cliff that it slid down. Here, over in this light color here, that occupies most of the frame is plateau material that has been reworked after the landslide that brought it down to the valley floor. In the right half of this light colored material, you can actually see a cliff right there. That's the top of the cliff. That's the cliff wall. This is the base of the cliff. You can see a cliff that has been eroded into this material after it reached the chasma floor. And these ill-defined, streaky, channel-like features look to me like that they represent surface streams, perhaps of water, that began redistributing that landslide material. Notice how the light-colored material laps on top of the grey rubble. And that would suggest that it's younger, that the grey landslide material is actually older. And thirdly, notice this medium brown material over here, this really smooth stuff over on the right-hand side. It's apparently smooth and featureless and looks to me as though it laps onto the light-coloured material, which would make it the youngest deposit in this frame. If it is indeed a relatively young sediment, could it be a lake floor the mud that actually forms on lake floors? I don't know. This is pure speculation on my part. You may say everything I've said up till now has been speculation, and perhaps it is. So, next one, please, Chris. So how do all these detailed observations fit together, and what do they imply for the origin and development of the largest valley network in the solar system? Here's my take on deciphering this image. In part, it's inspired by the story proposed by those professional planetary geologists for Hebe's Chasma, located at the very top left here of the... Oh, what did I do? Thank you, Chris. Whatever I did, he recovered for me. Hebe's Chasma up here. So first, let's look at the big picture. Valles Marineris appears to be made of two layers that underlie its floor and its walls, respectively. I think that the valley floor approximates to the top of a layer of erosionally resistant magma. Geologically, we'd refer to it as basalt in the grey, and ultramafic material, if you know what that is, in the chocolate-coloured brown. This material could be in the form of lava flows that erupted onto the Martian surface, or it could be as horizontal sills, as they called, which were injected underground along the layering of pre-existing older rocks. The walls of the chasmata would seem to be made of horizontal deposits of either sandstone or volcanic ash. Now, the growth of the chasmata is clearly influenced by the process of structurally controlled collapse of material into initially isolated pits and trenches aligned along fault structures. These fault structures have also controlled the emplacement of more magma as vertical dikes, maybe similar to that which underlies the valley floor, and maybe not. Where does all this magma, lava, ash come from? Well, Tharsis Uplift at the western end of the Valles Marineris is the largest, most long-lived volcanic center in the solar system. We still know very little about it, so we can speculate all we want. Suppose that instead of the uplift of Tharsis initiating Valles Marineris, which has been suggested by many people, suppose it was the magmas or lavas flowing eastwards as horizontal and vertical sheets that predetermined the 3D structure of the valley network. Why would the structural control over the vertical dikes be related to right-hand shearing? I have no idea. But these are first-order observations. Where does the material go to allow formation of isolated, structurally controlled collapse pits and trenches during valley initiation? In Hebe's Chasma, as I pointed out, the professionals suggest that salt layers were locally dissolved to allow for the sinkholes to form, and that the silicate materials, the non-salt material, of the plateau went down the sinkholes. But we've just seen that the isolated collapsed trenches and pits here appear to be associated with segmented magmatic dikes, which, believe me, are not easily soluble. Now, I can only speculate, and you should beware of those who speculate. But is it conceivable that the dike magmas were drawn down vertically before they had cooled and crystallized by a drop in magmatic pressure, thereby leaving lots of space above them in structurally controlled collapse, underground collapse? I don't know, but these are the kinds of models, these are the kinds of ideas that will be uppermost in the minds of planetary geologists, the professionals that do start to interpret this image, or have already done so but haven't told us about it yet. So how did the initial chasmata evolve into a broad valley network? In addition to the growth and the coalescence of initially structurally controlled trenches, we've seen clear evidence for at least three processes that would widen and steepen the initial valley network. The first two, instantaneous landslides plus slow ongoing crumbling of steep cliffs, combine to widen and lengthen the valley segments. The third involves various flow mechanisms to move material along the valley floor to empty and deepen the chasmata, including mass flow of landslide material, redistribution of that landslide material by streams and rivers, and processes possibly associated with localized lakes. Observation of the largest valley in the solar system, of how the largest valley in the solar system formed and evolved, is only just beginning. Is the story I've deciphered for you tonight valid? Who knows? It's going to require ground truthing to actually test that. Eventually, somebody will have to go there to see whether whether any of these hypotheses actually stand up to scrutiny. But my take-home message tonight is this. By releasing detailed images like this, the European Space Agency is allowing us all to participate, even at arm's length, in the deciphering of this story. Thanks for listening.
Just a couple of quick questions. So are you suggesting that it was subsurface flow, horizontal flow of magma that caused the undercutting that led to the collapse of these pits?
No, what I'm suggesting is that the erosion down through the possible sandstone and volcanic ash, that was easy. But once you get down to a layer of mafic magma, basaltic magma is strong stuff as far as erosion is concerned. That could have been older lavas, which flowed out over the surface, onto which volcanic ash or sand was deposited. Or the sand or volcanic ash, the light stuff, could be the older material. In that case, it could be a sheet or series of sheets of mafic magma which flowed out horizontally. That would define the floor of the mature valley. To define where the walls are, that would be related to vertical sheets of magma, which may or may not be the same magma as in the horizontal floor, because they could be later. So there are lots of variables and unknowns, but from this image, just looking at the textures, the structures, and the color differences, you can put together a story like this, which of course is a hypothesis, which requires testing.
Do the crater counts on the floor vis-a-vis the crater counts on the upper plateau give us any indication of the age of the actual valley formation?
That I'm uncertain of. However, since I haven't looked at it systematically, but given that you've got a process whereby even after the impacts in the plateau surface have occurred, you then eroded into that plateau, and you've got all of this active erosion and deposition going on in the valley floor, that would mean that in fact you didn't have a preserved record. And the fact that there's not much in the way of impact structures in the valley floor still doesn't enable us to then calibrate the age of the floor.
Simon,
Paul.
now that Mars Express has taken these photographs, you have a still photo now. You can from time to time check if there's any type of motion, could you not, with this type of magnification?
Yes, you could. But you know, Paul, I would very, very much doubt that there's been any significant volcanism along this segment of the Mariner Valley since about 3.8 billion years ago. However, when people are looking at the Olympus Mons, which is the largest volcano in the solar system, and it's just on the northwestern edge of the Tharsis uplift, if you just look at any of the Martian images, satellite images, the thing that strikes you is how smooth it is. There's very little in the way of impact structures on the top of this gigantic volcano. And the interpretation is that the surface volcanism, the lavas that covered the top of the volcano, are as young as 10 million years old, potentially. So it's not out of the question that some of this magmatism in the valley might be young, but I doubt it.
Simon, Mars's gravity is about a third of Earth's.
Mm-hmm.
What does that do for all the theories? Like, I mean, we can't compare Mars to Earth in terms of geological activity, can we?
But what that's going to do, that means, for example, that the response of rocks to gravity will be lessened.
Like a talus slope?
But you're still going to get them. It's just that maybe the size may vary.
They're more pronounced.
The actual velocity of material coming down a slope may vary. But remember, in this image, although those cliffs look like they're vertical, there's a 4 times a vertical exaggeration in the image. But it's a little bit like Mercury. If you look at Mercury and compare the surface of Mercury with the surface of the Moon, it turns out that the topography is much more subdued on Mercury than it is on the Moon. Why? Because Mercury actually, despite its small size, has a very large metal core, and therefore the gravity of Mercury is significant. And so it will have an impact on the precise details of the topography, but the actual processes that are occurring won't necessarily be affected.
What is the gravity on Mercury?
You have to ask one of the physicists in the audience. I'm just a simple geologist.
Half of Earth?
I don't know. I cannot tell you. Oh, no, sorry. I was actually reading quite recently that I believe actually it is comparable, but I can't support that.
Simon, I was wondering how deep these canyons are, say, compared to the...
They are kilometers deep. So when you see this impression of depth, it is real. If you were standing on the edge of the cliff, you better not have vertigo. I've been to the Grand Canyon. I got vertigo just standing on the car park, at the edge of the car park.
When interpreting an image, especially on such a large scale as that, wouldn't it not help to also have a contour map so you can see, which areas on the floor really do have the lowest elevations, relative to regions around them?
That, in fact, is what they did with Hebe's Chasma. And when they released the Hebe's Chasma image like this, they released the, what's the word for it? The digital elevation model. And so you could actually see in the digital elevation model that the sinkholes that they were proposing were actually, the big one at the very western end is actually 5 kilometers deeper than the average floor of Hebe's Chasma. But you're right. If they had also released the digital elevation model for this would have been an excellent cross-check.
Yeah. Grand Canyon compared to, what would be the ratio of Grand Canyon to this height?
In terms of height, I don't know, but I can tell you this, that you know that at the very western end of the Mariner Valley, there's the Noctis, Labyrinthus Noctis, I think it's called, which looks like a labyrinth. It actually looks like a city plan of right-angled canyons. Well, the length of the Grand Canyon would fall into that.
Marineris is about the length of the United States.
It is. East-west. It actually will go from Los Angeles to New York. It is huge.
So the Grand Canyon is only 400 miles long, I think?
Something along those lines. If you're asking me for numbers, I often don't have them in my head. Geological processes, I got at my fingertips. Thanks again.
Fascinating as always. I think I recall reading the average depth of that canyon is on the order of 10 miles. So it's about 10 times deeper than the Grand Canyon. All right, just a few closing notes. We're running a few minutes over, not too bad, considering some of our previous sessions there. Just a couple of notes. Again, just a reminder that on December the 21st, Friday, we do have a winter solstice celebration here at the museum. We're actually still looking for volunteers in terms of helping out. So for those of you that would be interested, I think there's still time to get a check.
We certainly need more volunteers for this. It's a tough night to get some people out, and yet it's a very popular night for the public, particularly when you combine it with the talks at museum on the main culture and calendar. So we really need some more volunteers. You do have to be security cleared to be a volunteer here, but for anyone who wants to join who isn't cleared, it's an easy, fast process that I can help you through. So we'd welcome some more people to join us, please.
So yes, if you do have bandwidth on that night, we would certainly appreciate the help. And think about it this way: you're going to learn about why the world is about to end with the talks that we have going on inside.
Hopefully you'll be learning why it will come to an end and it will be a Saturday.
So great. So if you can help out, that would be wonderful. Also, a reminder that we finally got the bookstore here at the museum to carry copies of the Observer's Handbook. So for those of you that aren't members, you should be. But if you're not and you'd like the Observer's Handbook, this is a classic work, contains a wealth of astronomical data. You name it, it's in there in terms of like eclipses, meteor showers, planetary data. The gravitational strength of planets, I'm sure is mentioned in there. So I encourage those of you that aren't members, that don't get this as part of your membership, to buy a copy at the bookstore if you're going to get one, because if they don't sell what they've got, they may not continue to carry it in subsequent years there. So just to let you know that it's there. What else have we got? Estelle's pick of the month, How I Killed Pluto and Why It Had It Coming. Yeah, that's going to be a controversial piece for sure. So if you're interested in what happened to old Pluto there, go see Estelle. Yes, thank you for the reminder, Chris. We were at the end of 2012, our final meeting of the year. We've got, I think, it's going to be an exciting year coming up with the advances that we are making at things like SmartScope, the renovations that are going on at Flow. I think it's going to be a very dynamic year for us, and I'm really looking to encourage speakers. We've had a number of first-time speakers come up this year. I'd like to see more of that. So if you've got something that really interests you and you've wondered whether you should give a talk, please, I encourage you to come on up and give it a try. It's not as intimidating as it seems. And so if you need, the subjects are pretty broad-ranging. Anything related to the science of astronomy, you can see we've got a bit of a list there. Really, the floor is open to it. So if you think you'd like to give a talk in the coming year, please contact me or Chris. My email address is up there. You can suggest the type of talk that you'd like to give and when you would be prepared to give that. We suggest certainly for presenters, first-time presenters or presenters that haven't done too many of these that you check out the guidelines on the website. We'll provide help. We'll provide help in setting it up. And again, for those first-time presenters, I encourage you to send me a synopsis of what it is you want. Just a few paragraphs or just a few lines telling me what it is you'd like to cover, and that helps us to establish the length of time that you need because we like to be on time here, right, Chris? Right. We try. So please, if you have something that you'd like to share with the rest of the membership, I encourage you to do so. And our usual tail end slide there. Estelle is with us obviously tonight, so the library will be open. Al obviously is here. Ann and Art are ready to fill those caloric gaps. You can see Art about your RASC membership and membership info and cards. Stephen is not here, I don't think, No? Stephen?
Well, you can always do your magazine
Yeah.
renewals by email with Stephen at a
That's right.
discount over the normal rate.
Again, reminder that the rest of the museum is closed, and we have our meeting over at Kelsey's for those of you that are interested in a different form of caloric satisfaction. Tonight we had 102 folks in the audience. I thank you for attending. I want to wish you all a wonderful Christmas, since we won't see you again until January, and hope you have the best of the holiday season, that you get a lot of astronomy toys and need to clear out those old ones, and you know where to come, right? Yes, sir.
Stay away from the garbage scopes from Sears and Canadian Tire.
Good suggestion. If you're thinking of buying, I probably don't have to say that to the membership here. They've heard us enough times, but you never know. If you're thinking of buying a telescope for a young person or something like that, stay away from the stuff that you'll get at Canadian Tire and Sears and that. It's not worth the money. Go down either and talk to the folks at Focus. They'll steer you in the right direction with some quality equipment. Do some research, shop on the internet, but stay away from the garbage scope. Or see Gary.
They did have a 15 by 70 Skywatcher Celestron for $50 the entire last weekend.
Oh, really?
And they have hundreds in stock.
But Celestron is a very good name, so you can't go
That
wrong.
was a good, really good deal.
That's why.
And if all else fails, go talk to Gary, because he can buy anything for you. He's the man. He has the connections. There you go. So our next meeting is Friday, January the 4th, 3 days after the New Year. So drag your weary tails in here and come for our meeting. And we're assuming, of course, that the world will not end on the solstice. I hope to see you all here. Again, wishing you the best of the holiday season and a great New Year, and look forward to an exciting year coming up in 2013. Good night, one and all.
Thank you.